So I'm Josh Birds. I'm the lead strategic spatial computing architect for Amazon Web Services. I work directly with some of AWS's biggest customers, figuring out how do we build the next generation of technology, including, and not just talking about it, I build this stuff. So, actual programmer here, but I do talk on occasion. All right, so biggest challenges that we see as builders that are building these metaverse or spatial type applications are challenged in three different areas. Identity, whether how we relate individual 3D assets back to individuals, or just in general, how do we give access to 3D information within this given data plane. Visualization, whether that is tools like Unreal, Unity, O3DE, Babylon.js, 3.js, take your poison. There are different visualization tools and different hardware that you need to utilize. And so that's just a big old challenge unto itself because there's so many different ways to do it. And last but not least, it's data. How do you take what you are going to visualize into that visualization itself? Where are you getting it from? How are you looking at it? How are you making it into something that's 3D or something that's understandable by individual people? So today, we're going to talk about that data piece. Identity and visualization are a huge challenge unto themselves. Our strategy at AWS really relies around three different areas in spatial. Create and manage that spatial data unto itself. How do you host it? How do you deliver it? Those kind of mechanisms. The second piece is building and creating an operational model with spatial information. So how do you build that visualization? How do you do CI or continuous improvement and continuous deployment pipelines? How do you test those applications on a regular basis? It's a real challenge. And then the last bit is deliver an interaction. How do you deliver that application? Are you using an MDM or mobile device management to deploy the app? Are you using WebXR and just creating a browser page? Or are you doing pixel streaming where you're rendering in the cloud and streaming the entire solution down to the device? There are multiple ways to deliver, and we're looking at all of them. Today, we're focusing on spatial experiences at scale, though. These spatial experiences have to, or else we're going to be in a roundabout movement of making an application, a bespoke application, every time we make one, an application for a single use case. In this case, we need to make applications that are worth more than one use case. And that's why we're going to talk about spatial data planes today. You need to manage your spatial data, and that's why we have spatial data planes. It's a singular location to store your data, distribute it, and apply compute, such as conversion, optimization, decimation. Well, basically pick your poison, whatever you want to do with your data. And it doesn't just have to be 3D data. We've done things as far as doing cancer research data and being able to analyze that and produce it into a methodology that can be visualized in spatial. Now, using a spatial data plane will scale that information to yourself more than just one application. So if you're going to download into a VR application some 3D data and visualize it, now that you've got it stored in a spatial data plane in the cloud, you can then access it from a different application that you might view in a browser or something that you might view in a mobile device. And that is something that AWS has built today and that we've open sourced. So for the developers in the room who don't want to hear me do a sales pitch, scan the QR code. That goes to a GitHub repository that has the code. We open sourced it back in November, about a month ago. This is a tool that we have developed over the last 3 years in the course of prototyping and building different spatial applications for our customers. Did you get to that URL just fine, miss? Okay, fantastic. Now I know that works. Everybody got it? All right, I'm going to go ahead and move forward. So our customer challenges. We really look at where our customers have problems when it comes to spatial data planes. A lot of the time, it has to do with cost. You don't want to pay for something that really should be used over and over again, and it may even be just, you're going to go buy something off the shelf. It may not be built for you, so you need to modify it again, so then you're incurring additional costs for modification of off-the-shelf software. The other thing is secure and centralized asset management. How do you take that and distribute and store it securely and make sure it's distributed securely to your endpoints? An easy distribution at runtime, how can I access it with just a URL and just some authentication measures? So what is it? We have made a visual asset management system. It's a place where you can store your 3D and 2D content, not just visual either. It can store anything kind of object data, file data onto AWS. There's a management framework that handles that data. And what we don't talk a lot about, but is a huge piece of it, is that compute piece, where we can apply containers to individual assets on demand. And we call these pipelines. The core features, you upload the data and manage it how you will. We have version control utilizing S3, or our simple storage service. Sometimes you got to remember what that acronym stands for. And then you utilize that base level service on AWS to manage the assets along with metadata that may be stored. Then you can visualize that in 3D, and I do not know why we have VR up there, but we're getting there on the VR portion. But the 3D portion is visualizable within a browser while you're looking at the asset. And the next piece is pipelines. You can create a pipeline which is a singular Docker container. You can do whatever you want with that visual asset. You basically download it into the container, process it, and output a new asset which goes into the database. And the next piece, which is even more fun, is you can string those pipelines together to create a workflow. Say you're bringing in a step file from SolidWorks. Now you're going to convert that to a GLTF, for example. Then utilize that unto itself as a container. Now you can stick another container in that workflow to be something that auto-textures based upon the different materials within that step file to the bodies within the given GLTF. Any questions so far? Am I going too fast? All right, great. So those workflows are really powerful because you basically chain together multiple things and create multiple derivative assets. And you keep track of that digital thread. You have all the root asset and all of its children that are created, which is great for not just basically conversion workflows, but also scientific workflows as well. For all the nerds in the room, including me, the builders, here's your AWS architecture diagram that you may generally see within tools like reInvent. To give everybody a general gist of it, this right here is just a simple React app, web app that you can build that we power the 3D portion with Babylon.js. You can swap out multiple pieces of it to make it how you will. But I really don't care about you using that piece. You can rip that whole thing off and I don't care. This is the power behind the tool. This is the API calls. It's all RESTful API calls today. You make access to what we call Lambda. AWS Lambda is programmed with Python. And believe it or not, it's a very simple and very addictive scripting system on AWS that has access to all of AWS's power. So you can give access to S3, our storage service, to access the information, download it into a Lambda function, kind of like you would do a Python script on your laptop, except it's powered by the cloud. Lasts for about 15 minutes at max. The other piece we utilize is DynamoDB. This is our NoSQL managed database service. So it's horizontally and vertically scalable. So for those of you that have actually messed with databases, you can go big as you want to with Dynamo. We're also looking a little bit into graph databases right now, because this relationship matrix between the different assets can be, let's call it complicated. Last but not least, this is the pipeline functions, the step functions. This is where all the containers are strung together, which are stored in Elastic Container Registry. And now I've just dropped a bunch of acronyms on you in no time at all. Ultimately, this leads to the idea of a data plane. Now, what I just showed you could be employed by multiple organizations to be spatial data planes between multiple companies. What these companies can do is then rely upon a singular centralized identity federation service. When you do that, you can then make this something where you sell your data to an endpoint and license it on demand. Because one of the most powerful things today that we have as a consumer and as a producer is our data. We can take the power of that and sell that at will now, utilizing a system like this. And people can own their own assets. And then companies can license their 3D objects and their AI algorithms on demand and make money while they work. Call that the end of it. Any questions? Seriously, you can go technical on me now. It's really quiet. Some additional system diagrams. Nothing really pretty here. Oh, right, I forgot to go here. Here's the front-end user interface for accessing the assets as it is today. So you can search, access, you can see the file extensions, etc. So this is just out of the box, simple React web app. And here's the web page for accessing and visualizing information. In this case, this is a CSV file. Somebody wanted to see the STL, a stereolithography file, converted into a CSV to visualize. I really don't understand why we did that. But we can also do 3D plot diagrams. But basically, you can use any kind of 3D visualization within this piece. We've even gone as far as visualizing HDRIs, or highly dynamic resolution images within this. And here's the workflow for creating a pipeline, or workflow. An individual pipeline is selected, and then we can also select the asset that will be executed against. So it's a drag and drop interface. That's it from me. Thank you.
Visualization of Unreal Engine assets directly?
Repeat the question, please.
Do you have an integration with Unreal Engine?
Integration with Unreal Engine. So any kind of integration unto itself, not today. So this is all API calls.
Okay.
So if you know how to build the RESTful API interface, you could do a direct integration with the engine itself. Where the real power would come in is actually at runtime, after you have compiled the asset, making the request to the individual assets themselves to download into the engine and instantiate. That way you can basically have one asset that you update all the time to change it while it's after it's compiled, so you're not having to change the application itself.
Okay. You showed the visualization of the 3D asset, right, in the screen?
Yep.
So what type of files you use?
Natively today, it's like the CSV, the GLTF file formats, but that's all Babylon.js. When we are even attempting to integrate 3.js. So that front end to itself can be modified by you if you got some JavaScript experience.
Okay.
And be able to introduce that.
Okay, that's perfect. Thank you.
Thank you. I'm scared. He wants to ask a question. Yes, Kurt.
So you mentioned that it can handle other types of data besides 3D. So how does that work, and how does that handle it if you need to put up, let's say, just a generic CSV file or other data that's associated with, let's say, the 3D data as part of that?
So you would upload the CSV file as is today. So that's just how it operates. It can upload any kind of file format that you want. Then you would have to create a container that processes that, and then you can download it on demand. So it's just any kind of object data, to be completely candid.
Can you link that to right now, like other 3D data? So if you had like a bill of materials list in there and that linked to, let's say, a GLTF file that had was converted from CAD, can you link right now the two together so when they come down it knows to bring that as a package down, or?
So not today. That would have to be something you write in the container itself to access that, or a list of files that it would need to know to access within the database itself.
Okay.
Any other questions? Oh, good.
Hey, you mentioned it does decimation as well. How does this like relate to something like Ventana? Would this substitute as a replacement or?
Repeat the question, I apologize. I'm trying to hear.
So you mentioned it does decimation as well.
So that is something you can introduce. Those Docker containers are code you write. So
see.
you could do, if you could somehow containerize tools that are coming from Max or Maya, or if you can find some Python algorithm that does quadric edge decimation or quadric edge collapse, that could be your decimation tool. I've been playing around with some stuff around voxelization myself.
Cool. All right. Thank you.
Any other questions? I feel like I keep asking that. Oh, geez, Kurt, I don't want you to ask more. I know what you're going after. All right, well, thank you, everybody.